So this video is on chapter 1, classwork 6. This is problems 1-64 to 167. Okay. So on this, again, this video, you're meant to try these problems first. This is a guide or a reference for you to double check problems that you're having trouble with. So on this first problem, what they want us to do is they want us to practice writing things in expanded form. And this is where you have to be careful and really pay attention to what they're asking us to do on this. Number one is should be simple for us. I'm going to take y and I'm going to have 7 of them. 1, 2, 3, 4, 5, 6, 7. Let me just double check. 1, 2, 3, 4, 5, 6, 7, and that would be y to the 7th in expanded form. Now, what you have to be careful of is one like number 2. Only the 2m is being raised to the power 3, not the 5. The 5 is not being raised to the power 3. So the 5 is going to stay. What's going to be raised to the power 3 is the 2m. So I'm going to go times 2m times 2m times 2m. Okay, that's what it would be in expanded form. Now, the next one, what we have here is we have this x to the 3rd that's going to be raised to the 2nd. So I'm going to have for this an x to the 3rd times an x to the 3rd. I have that twice. Now I'm going to expand each of those. So my x to the 3rd is going to be an x times x times x times my other x to the 3rd is going to be another x times x times x. That's expanded form. On number 4, the 4 is not being raised to the power 5, only the x's. The y is the only thing being raised to the power 2. So this is going to be 4, and then this x to the 5th is going to be x times x times x times x times x. And then the y to the 2nd, change that color, the y to the 2nd is going to be a y times a y. So this is how it would be written in expanded form. Now, if I was to compute these, just so you understand, this one would have cleaned up to being y to the 7th, which is what I started with, but they wanted it in expanded form. This one here, if I take 5 times 2 is 10, times 2 is 20, times 2 is 40, I would have ended up with a 40 m to the 3rd as my final answer. Okay, again, they want it in expanded form though. This one here, x to the 3rd raised to the power 2, is an x to the 6th. Power to power, we ended up multiplying. 3 times 2 ended up being 6, but this is what it is in expanded form. And on number 4, this would have been 4, and then it would have just stayed as x to the 5th, y to the 2nd. That would have been the answer. But again, they want everything in expanded form. You did not have to write what I just wrote in black. 1-65. Miss Wang had just explained to her class how to write a simpler expression by using the number 1. She wrote the expressions at the right on the board. And they want us to take a look and explain kind of what happens, and we're going to kind of do the same on ours. Now, I don't need you to necessarily write out the big one, okay? But if I was to just redo her problem here, we have an x to the 2nd, y to the 8th over an x and a y to the 2nd. What she did was she try to get some like things here, okay? So in terms of the x, okay, she did an x over x, but on top, I still had one x left over. And then the y's, I have 2 on top and bottom that I can cancel. So she rewrote 1 as a y to the second. And then we were left with a y to the 6, sorry. And on bottom, we had a y to the second. So this right here is really my x to the second. This right here is really my y to the 8th. Now, what you'll notice is I have this that makes a 1, x over x cancels out, makes a 1. I have this that makes a 1. And then what am I left with? Well, I'm left with this x and I'm left with this y to the 6. That's how she ended up with her final answer being x, y to the 6, okay? So you do not have to physically draw a 1, but we want to be cleaning up ones, okay? So on number 1 here, I notice that we have 1 x on top and 1 x on bottom that we can cancel out or make a 1. And I am going to end up with an x to the second as our final answer. Now on this one, okay, what you can do is the following. Okay, we can, if we're looking at this, I notice that I have a y to the second on the bottom. I'm sorry, an x to the second on the bottom. So that means I can take 2 x's from top and bottom. So I'm going to have an x to the second, and that leaves me with 3 out of my x to the 5th. Okay, so she's doing it like this. And I'm going to kind of explain how I personally would do this. I usually don't break it up like this. I think it, but I don't write it out. So this x to the 5th, I wrote here as an x to the second times an x to the third. This x to the second on top and this x to the second on bottom make a 1. And I am going to be left with an x to the third over y. Now, the way I think about this, okay, is I look at this and go, okay, if I'm looking at my x's, okay, I have 5 of them on top. I have 2 of them on bottom. The most x's I can take from top and bottom are going to be 2. So I can take these 2 here. They're going to be completely gone. Here, when I take 2, I'm really going to be left with 3. So my answer is going to be x to the third y. On Roman numeral 3, what we notice is we have a k squared on bottom, which means I can take 2 k's from top and bottom. That's the most I can take. So what I'm going to do is on top, I really have 8 on top, okay? So what I can do is I'm going to take 2 from top, which gives me 6 left over, and 2 from bottom, which cancels out, and I am left with x to the 6th. Sorry, k to the 6th. So I'm taking this, and I was left with 1 there, which gave me 6 total. On this one, this is, now I have a 16 and an 8. 16 and 8 are normal numbers. So if I'm looking at that 16 over 8, can I reduce 16 over 8? Well, 16 over 8 really is just a 2. That's just going to be a 2. That's just going to be a 2. And then when I'm looking at my z's, I have 3 z's on top. I have 2 z's on bottom. How many z's can I cancel out? 2. How many am I going to have left? 1. And where's that z going to be? On the top. So my final answer is going to be 2z. Now, in this situation, we are dealing with scientific notation, okay? Now, you can kind of think of this with the 12 and the 4 just as a regular 12 being divided by 4, which is going to give us a 3. Okay, so I am going to have 3. Now, when I'm looking at my 10, I have 10 to the 9th, I have 10 to the 3rd. That means I can cancel 3 of them from top and bottom, and I am going to be left with 6 of them. Now, the way I'm going to write this is in scientific notation, so that's going to be 3 times 10 to the 6, and that would be our answer. On Roman numeral 2, for this one, my 8 is going to be squared, and my 10 to the 3rd is also going to be squared. That's really what's happening right here. Okay, both of those are being squared. So that is going to become a 16, and 10 to the 3rd raised to the 2nd, power to power, we multiply, and that is going to be 10 to the 6th over 4 times 10 to the 1st. Now, I'm going to look at this, and the 16 over 4 is really just a plain old 16 divided by 4, which is 4. So I am going to get 4. And then when I'm looking at 10 to the 6th and 10 to the 1st, I have 1 that I can cancel from top and bottom, and I'm going to be left with 5 of them. So that's going to be times 10 to the 5th. So my answer is 4 times 10 to the 5th. That is going to be my answer. On 66, they want us to decide if these are true or not. So we're going to be cleaning up all of these. So looking at this, when I have an h to the 3rd times h to the 4th, that is going to become h to the 7th. I add the exponents times k. And does that equal this? No. Okay, not equal. On B. Okay, so again, we're trying to see if we get the left side. So if I'm looking at my 39 and my 3, 39 divided by 3 is 13. So that works out. If I am looking at my p to the 4th over p to the 2nd, I have 2 p's I can cancel from top and bottom. I'm going to be left with 2 on the top. So far, so good. Then if I'm looking at my q to the 5th over q to the 2nd, I can cancel 2 q's from top and bottom, and I am going to be left with the power 3. So this one is yes. Those are the same. On C. So let me look at my 9s. Okay, so I have a 9 to the 2nd over 9 to the 3rd. I have 2 9s. That's the most I can take from top and bottom. Now, when I do that, I am going to be left with 1 9 on the bottom. when I am looking at my 5 to the third over 5 to the second, I can take 2 5s from top and bottom, and I'm going to be left with 1, and that's going to be left on top. So this one is, yes, these are equivalent. On D, so I have 3 to the fifth times 3 to the second. And by laws of exponents, I'm going to add those, and that's going to become 3 to the seventh. It is not going to become 9 to the seventh. So this is not equal. Okay, I do not take 3 times 3 and get a 9. I have 3 7s. That's what happens. I'm sorry, I have 7 3s. I apologize. On the next one, I have to kind of be careful here, thinking about my math. I'm going to take a 9 divided by 0.5. So think about how many halves in 9. So how many halves in 9? Well, there's 2 halves just in 1. So 9 divided by 0.5 actually is going to be an 18. And then when I am looking at my 10 to the 6th and 10 to the 6th, those are going to cancel out. If you want to think about it, I do have times 10 to the 0, but we learned that anything raised to the power of 0 is just a fancy 1. So my answer is 18. So this is yes. On F, I'm looking here at my W's. I have 2 W's on top and 5 W's on bottom. So when I'm doing this, I'm going to cancel 2 on top with 2 on bottom. And that's going to leave me with 3. But where are those 3 going to be? They're not going to be on top. They're going to be left on the bottom, which really means this is a 1 on top. So this is no. Okay, on this one, I'm going to have to do a little math. Okay, so on the top, when I square this, what's happening is my 7 is going to be squared. And then my 10 to the third is going to be squared. Now, 7 squared is 49. And 10 to the third raised to the power 2, power to power I multiply, that's going to be 10 to the 6th. Then I still have it divided by 3.5 times 10 to the second. Now, when I'm working this out, I want to think how many times does 3.5 go into 49? Well, 49, 3.5 is half of 7. So 2 of them goes into 7. And 7 7s go into 49. So if I end up doing this, we're going to end up with 14, but you can also see that here. So if I was to take 49 divided by 3.5, you see I do get 14. So that is going to equal 14, which automatically is not going to give me the right answer here. And then let's just kind of work the rest of this out. I have 10 to the 6th and 10 to the second. That means I'm going to get times 10. And then I can cancel 2 from top and bottom. So I get times 10 to the 4th. Now, that is not officially scientific notation. If I was going to write this in scientific notation, this is a 14. I need a single digit in front of my decimal. So I need it to be a 1.4, which means I would have had to move my decimal 1 place, which would have been 1.4 times 10 to the 5th. That's really what this was. So this is no. On H, so if I'm looking at my numbers, my 5 and my 10, 5 divided by 10, I can take 5 from the top and 5 from the bottom, and I am going to be left with 2 on the bottom. Okay. And then when I am looking at my g to the 50th and g to the 5th, I have 50 g's on top, 5 g's on bottom. I can cancel 5 from top and bottom, and I'm going to be left with 45. And so this one is yes. And on the last one, when I have a power to power, what I'm going to do is I'm going to multiply that, and that's actually going to be x to the 8th, not x to the 6th, so this is no. Now on 1-67, they want you to come up with 4 different ways that you can write x to the 12th. And they basically want one that's going to involve multiplication, one that's going to involve parentheses, and one with division. So basically you want to have where you have x to some power, for example, times x to some power equals x to the 12th. And you want to figure out what you could put in there. You also want to have something where you have x to a power over x to a power, and that ends up giving you x to the 12th. They want you to do something with parentheses, so maybe x to some power raised to some power equals x to the 12th. And then you can have a fourth one, and you can do any other combination of these that you would like. Hopefully this helps you out. Be creative on that.